Welcome to section 10.6, which will be on muscle tension in skeletal muscle. Muscle tension is going to be the force generated when a muscle is stimulated to contract. And through lab experiments, we can measure the tension in a muscle and we can provide it in a graph form, which is called a myogram. So when we look at a muscle contraction, if it is just due to a single stimulus, this is called a muscle twitch. And we look at the minimum voltage that is triggering the twitch, and that will be termed our threshold. Now let's take a look at this myogram over here to the right. We have these different periods. We are looking at the muscle at rest here, and at this point here, we have stimulated that muscle, meaning we gave it an action potential or a nerve impulse. And we have a short period called the latent period. This is just the time after the stimulus, but before contraction begins. And we see that there's no tension within the muscle here. Then we have the contraction period. This is the time when tension starts to increase. And it begins as those power strokes are pulling in those thin filaments until we get that maximal contraction. After that, we will have a relaxation period. This is when tension is going to decrease back down to our baseline, and we start to see a release of all of those cross bridges, and generally this lasts a little bit longer than our contraction period. And we are going to be able to gain more motor unit recruitment as our muscle is stimulated repeatedly. So as the voltage starts to increase, and we could see this in the graph over here, voltage is increasing here, we see that more motor units are being recruited to contract. So recruitment is also called multiple motor unit summation. It's explaining how our muscles exhibit a varying degrees of force. And I really like this photo down here that shows you over here we have no muscle fibers being recruited. Same thing here at the number 1. At the number 2, we start to recruit a little bit. And as we're increasing voltage, we start to get more motor units recruited until we have reached our maximum contraction. We have no more muscle fibers to contract or to recruit. So you might think that this region over here where we have just a slight amount of recruitment is when we would use a few motor units in order to lift a pencil, whereas we might need our maximum contraction in order to lift a suitcase. And while we're recruiting, we also are going to base it on the size of our motor units. So when we're trying to pick up that pencil, we're going to recruit our small fibers first. So here's motor unit number 1. And then as we are attempting to lift that suitcase, we are going to start to recruit more motor units that go to larger fibers. So here at motor unit 3, and then of course we have all these other motor units recruited, we are going to be able to lift that suitcase. The next term we need to describe relates to changes in stimulus frequency, whereas the previous slide we were talking about stimulus intensity. So here we are going to discuss wave summation, which is also known as temporal summation. It's when we have our stimulus frequency set at about 20 per second. We have relaxation that is not completed between each of these twitches. So you can look at this photograph down here where we are having contraction or tension taking place in our muscle, but before this muscle can go back down and relax, another stimulus is given and we are building more tension. And then before that can relax, another stimulation is added. So all of these arrows are representing a stimulation, and then it's going to build upon that one, so that these contractile forces are added up to produce higher tensions in muscle. Whereas in this graph over here, we are seeing less frequency, so less than 20 per second. And so that muscle is allowed to relax back to its resting state, and then another stimulus is given, and same thing happens over and over again. Now, let's talk about incomplete tetany and tetany itself. If frequency is increased further, our myogram is going to exhibit what's called incomplete tetany. So this is when we have tension that is increased and twitches are happening partially. So they're just partially fused together here. But if our frequency is increased further, for example, we have about 40 to 50 per second, then our myogram exhibits this tetany that takes place. Here, this tension is nice and smooth without any relaxation taking place. And if we have high frequency stimuli, that may lead to fatigue, in which that muscle cannot hold that tension anymore, and we start to see a decrease in tension production.